One thing that we didn't hit very hard before we left for break that I certainly would have gone over if we had met face to face on Tuesday um, was the central limit theorem and exactly what I'm expecting of you for that. So let's do that quickly here. It's really very simple, and I'll tell you that it's the last few questions on the test, and they're going to be nearly identical to what I'm going to do right here, but with maybe some small differences. Same order, same kind of problem. Remember what the central limit theorem says. It says that if you got a population with a mean and a standard deviation, any population, associated with that, there's a distribution of sample means, meaning if you were to take a bunch of different samples of a particular size and record the average for those samples, those averages are going to be normally distributed. The mean is going to be the same as the mean for the population that the samples came out of. But remember this computer simulation we did in class, the population was spread out, but when we did this distribution for sample means, it was much narrower. The standard deviation was much smaller. In fact, it was the standard deviation of the population divided by the square root of the number of people in each sample, or the number of things in each sample. So an example of that is, if we look at IQs, again, just because the numbers are nice, not because they're important. If we look at the population of IQs, the mean is 100, the standard deviation is 15. So if we want to know the probability that a person picked at random from this population has an IQ of over 110, we would use exactly what's written there. We would do distribution, normal CDF, and we would say 110 to some really big number. I'm just going to go 200 from a sample with a mean of 100 and a standard deviation of 15. And we'd see that there's I typed it wrong. I typed a mean of 10, not a mean of 100. So a mean of 100 with a standard deviation of 15. We would get that there's a 25% chance that an individual selected at random from the population would have an IQ of over 110. Now, if you think about that distribution, right? We got our mean of 100, and one standard deviation up is 115. So we're talking about this chunk of the population. So that's about a quarter of the population, and I think that makes sense. What if we're looking at a sample of people, though? What's the probability that if we chose 20 random people from the population, that the average IQ for that group would be above 110? It's not that surprising for an individual, but it's going to be a little more surprising for a group selected at random to be that far away from average. So what we do then is we use the standard deviation for the distribution of sample means, because we're talking about the mean of a sample. So the standard deviation of that distribution would be 15 divided by the square root of 20, 20 because it's the number in the population, and that would be 3.35. So the probability that a group of 20 selected at random would be above 110, would be 110, sorry, I did it wrong again, 110 to 200 from a population with a mean of 100. I'm sorry, not the population, the sampling distribution for the mean has a mean of 100 and a standard deviation, what was it, 3.35. And that's extremely unlikely, 0.0014. Okay, now if you think about that, if we look at the distribution of sample means, it's got a mean of 100 and a standard deviation of 3. Let's just round that off to 3 for ease of writing this here. So 1 standard deviation, 2 standard deviations up, 3 standard deviations up, and we're looking at what's the probability we fall in that part of the population, okay? Or in that part of the sampling distribution for the mean. So extremely unlikely. So again, that's what you're going to need to do. the last few questions on the test are going to be, if you have a population like this, what is the mean and the standard deviation for the distribution of sample means? Just got to remember it's sigma over the square root of the sample size. And then I'm going to ask you what's the probability that a individual selected at random would be above or below a certain point, just like that. And then I'm going to ask what's the probability that the average for a sample of some size will be the same above or below a certain point. And you should end up with a much smaller answer for the second one. All right? Good luck.